Okay, so it's 35 past 9. I think we can start. My colleague Rui put a poll asking if you install R Studio both. The thing is, well, today we will start learning R, and we will need both, well, R and R Studio that are different. R Studio will be the it's called IDE, Integrate Development Environment. I think is the meaning of the acronym, and this will be helpful for us to develop our projects and learn the programming language. I will share my screen and start. I wonder if, well, as I normally say, if you have any questions during the lesson, please don't wait until the end. Just write the question in the chat, and I will either reply it at the moment or leave it for later. Okay, let me share my screen. So, yeah, a moment. So we are in this website. I will share that in the chat, the link. So it's yeah, today Tuesday, so we will start with the introduction to R. Just a comment, there is a new, one second that I will, yeah, now should be okay. Yeah, I was yeah, changing something from my, there is a new template in case that you want to have a look later at the lesson. This is, let's say, the old format, but the Carpentry's lessons are transitioning to this new format. It's pretty similar. I think the accessibility is better, and I think they have some like new features, but this is still like in a testing like a phase. Oh well, sorry, I'm not sharing this. So this is the new format. But I will use this one. I will share that in the chat in case that there is any doubt. This one. So well, first of all, we need to install R on RStudio. Here are the instructions for Windows, Mac, and Linux. Well, for instance, in my case, I installed RStudio in December, and when I opened it this morning, I got a notification that that is a new version. So I download the new version and I install it. Also, some packages that take some time to install are these ones. I will paste them in the chat. So in the meantime, you can open an R terminal and install them. If not, we will see later how to install them. So well, first we will start with a little bit of like an introduction of what is R, what is RStudio, and we will start learning more about the programming language. So for R, we understand that the R could be the programming language, and also could be the software that interprets the script that I mentioned script because R is not a compiled language like C, Fortran, C++. Is the is interpreted, is said, and we have a script with a set of instructions, and these are executed when we run that script. Why is important to learn R? Or well, this is like a here also rather than we are learning a programming language, but also we are learning some generic concepts. So here I will say that it's important. Like, why it's important to learn like a programming language like R or Python. Uh, I mentioned yesterday that this concept of make science reproducible is getting more and more important, and a programming language like R allows you to document and list a set of steps of the study that you are doing, like the research that you are doing with the data that you have, and you you can always publish this script and say, okay, I follow these steps in order to, for instance, to create this plot or to obtain these results. And rather than like what is said in the lesson, that pointing, clicking, and telling instructions of a graphical interface, when you write them, is like is easier to read, reproduce, etc. Also, R has more than 10,000 packages. So, for instance, if you work with some sort of statistics, I'm pretty sure that that will be like available on the there might be a package. Normally, what I do when I want to like I need to use a new feature of language, what I do is first I check if this there is a package that already implements that. In most of the cases, there exist. Also, it's efficient when we have a large data sets of hundreds of millions of lines. Are produce high quality graphics that these are important when we want to publish a paper or when we submit some research to a conference. We will see tomorrow that the visualization package is quite powerful, and we have a lot of features that we can use. R has a large and welcoming community. I mention sometimes, well, most of the times Google, but any other search engine, or normally when you search something in Google, the answer will appear in Stack Overflow or any other of in a forum. And here you can find some links of the. And also R is free and is open source and cross-platform. Doesn't matter if you have Windows, Linux, Mac, that you can run R. And making it open source is, allows everyone to contribute, and that's one of the strengths of this programming language. So what we will do is we will learn our way about RStudio. So I need to start RStudio, and what I will do is I will share my screen rather than share the One moment. Yeah. I need to click in. Yeah, sometimes it's a little bit takes some time to. Oh, well, I can share the. Not sure I think it's easier if I share the. So imagine that now you can see RStudio. What is explained here is normally you will get, well, when you open RStudio, you get something like that. You get here the main, is in the left part, you get the console that you get here a command prompt where you can start typing R commands. And on the right, you have two small parts of Windows. On the top right, you have some tabs, and well, the one that is highlighted is important is the environment. This is the memory that when we run when we read a file and we will create some variables, these variables will be stored in memory, and this is a kind of a snapshot of that memory. And here we will have on the bottom right, we will have a set of the files that let me check if so the first thing that we will do is we will create a project. So to create a project, I need to click on File and New Project. So here we have three different choices. So what I want to do is I want to create a new directory. Then I select a new project. Well, it tells you that create project as a subdirectory of. I will, well, for this example, I will use desktop, but you can use any other folder like a document or. And the directory name we can use, for instance, data carpentry or any other name that helps you to remember. So when I click here in create project, so the switching to project data carpentry. And you see now that in files, I have a file data carpentry.rprog that here is a save like the project configuration, but this is just a configuration file that we will not need to use. Also, if we want, we can create if we click here in a new file and R script, here we can use this file to take a note of what we are typing during this lesson. Just to show there is a in case that is mentioned in the documentation that in sometimes when you have an issue, and if you want to use ask the question in Stack Overflow or ask the question to a colleague, it might be useful to explain to say the R version that you're using, the libraries that you have loaded, etc. So what we will do is we will execute our first R function that is called session info. We can either to type this here in the at the bottom in this console. So it's a session info, and also what you get here a suggestion that in case that you want to use, you see here there is a yellow square that shows you some help about the and tells you print version information about R, the OS, and attach or load the packages. So if you click here in tab, it autocompletes. So it says session info, and because it's a function, we need to use well, it's a bracket, but in this case we don't use any parameters. And to execute that, I click in enter. So this is the output that I have. I have this R version. I think there is should be a newer one, but well, for this must be good enough, and tells you the platform that you're using. That also tells you the using Windows 10 and all of these definitions. This is in case that you need some help. That would be useful. That would be needed to include that information in case that they ask you for that. So I said that you can either use the console or also you can use this file here on top. So it's a session info, and to execute this line, let me see if I remember, I think was Control Enter. Yes. So to execute a line that is here in the script, you need to press Control Enter, and you will execute that line. Also, you will see in the documentation there are a lot of resources about R, where you can find the help, etc. And also for the what we have seen that when you start typing, you get some info here, but also you can, for some reason, okay, I see that there is a question in the chat that what is the okay, I so console is the when you okay, that's a good question. Terminal is what the terminal when you are using Windows, Mac, or Linux. This is the, let's see, the command line. Here you can do execute a dir, for instance, and tells you the list of where, if you are in Mac or Linux, you can do ls and get a list of files and directories. So you can operate with the operating system. But console is when you execute R, you get this prompt here, and you can execute R commands rather than the operating system commands. Also from a terminal, you can execute R and run R commands. So that's the difference between this is, let's say, to do operations in your system, but also from here you can, I think you can execute R, and you see, and it works. There is another comment in the chat that is how did I get this current workspace? What I did is I create a new project. So I click in File, New Project, and I chose a new directory, New Project. I chose here the name, and then I click in Create Project. And this is why I get this setup here. Also, to create a new file, I click in here in this bar. I'm not sure if the window is big enough. Here I create a new R script, and I got it this. Also, it's recommended to use when we are here in files to have to create some folders in order to make things more things like the files that we have to sort them. So it's recommended in the, for instance, we can create a folder that is data underscore row. So we need to click here in this new folder emoji icon and write data underscore row. So now I have this folder here, and we will create another folder called data. So in data row is where we will download the data, the data sets that we will work with, and once that we clean them and we have like a version that we want to save, we will save it in data. You can call it this names, or you can use any others. So it's up to you. But for now, we will create these two folders. And okay, so any questions before we move on? Okay, I see that there are no questions, so I will continue. So okay, now we will start learning R. So we will start with, let's see, the first step is creating objects. Here in this lesson, we will use objects and variables that actually for this lesson will be the same. If when you are moving to other programming languages, I don't know, for instance, C++ could be different, but for this lesson we will have variables and objects. We may use the same term. I will try to use objects. Or well, variable. Yeah, I will. We'll see. So to create an object of a variable, I need to choose, for instance, I will create weight kilograms, and to assign the value to the variable, you can either use the arrow, that is a way to, is alt minus, and you can write the arrow, or you can write it manually. I will type in the chat how this is. So if you use the combination of these two keys of the keyboard, Alt and minus, you will get the arrow. And you can assign there a value that could be 55. Okay, right. So if I execute that with Control Enter, you see that this is executing the console, And now you see that here in the environment, I have a new value. I have a weight underscore kilogram equal 55. Also, R is like could be used as a big calculator. You can write an arithmetic expression 3 plus 5, and you get the output is 8, where also you get a number that you can refer later on. You will see in that also you can use weight kilograms. You can use equal for assignment rather than the arrow. But in the lesson, also for readability and also to keep, because this comes from other programming languages that they use the arrow rather than the assignation, rather than the equal symbol. The recommendation is to use the arrow because when we will see later, when we use functions to give values to the parameters, we will use equal rather than the arrow. So remember that to assign the values to variables, well, it's like this is for readability and also to make things more. Yeah, there are like a slight differences to use the arrow. Also, there are some recommendations in order to choose the name of a variable. You cannot start the name with a number, so should be always a letter. R is case sensitive, so it's not the, if I execute the weight kilograms, you see that the first W is capital, will be different variable to the previous one. And yeah, so this is the okay, more also for here I'm using underscore to separate, but you can also use I think it's called camel case. That is you can, for instance, use my variable. So this, I think this is called a lower camel case, that the first word is in small letters and the subsequent words are capitalized. So this is regarding variables. Also, it depends when you work in bigger projects, it could be that they have a style guide. This style guide tells you how to choose the name of a variable. For if the script is for you and this is like it's a tiny project, doesn't matter that much. But bigger projects, they follow popular like style guides that tells you how to choose the name of a variable, tells you how to, let's say, tells you the style of that you have to follow to write code. Okay, here there is another example that is we can create this variable weight in that will be you can use 2.2 and multiply by the weight of in kilograms. What you see here that you get some the suggestions. So when you execute that, you see that now you have two variables, so weight kilograms, 355, and weight in pounds, 121. And this is a concept that here, for instance, if I use weight kilograms and I update the value and I use 100, if I update that, would you think that this variable will be updated, the weight in pounds? So I forgot to mention to include a comment is the you need to write a hash and you can write a comment. So when we calculate the weight in pounds, we took the value of weight kilograms at that time. So if I execute this, oops, Control Enter. If I execute this, as you see that the weight in kilograms is updated, is 100, but the weight in pounds is not updated because there is no relation with, well, okay, there is a relation, but here we took a snapshot, we took the value of weight kilograms at that time. We will need to execute again this line in order to update the weight in pounds. So this is okay. So this is regarding variables. For a comment again, you can use a hash and write the comment. And now we will see, now that we are familiar with the variables, so we will talk about the functions. So we can say that the weight in kilograms is, we can assign the square root of 10. So for the functions, I use brackets, and inside the brackets, I specify the parameters of. So when I execute that, you see that the weight in kilograms is updated to this. Also, in case that you want to execute that and you want to see the value, if you use a bracket, if you execute something between brackets, and you execute it with the Control Enter, you see that at the bottom, you execute this, and there is an output. So here you see the difference. Here there is no output, and here I show the result of this operation, of this function. Also, okay, more functions that we can use. Well, there are many, but these are only examples that we are using just to learn about more about the arguments that. Also regarding, we will use now the function color round. For instance, if you want to know more about this function, you can, well, when you type it, you get some information here. You see that we have two arguments, we have x and digits. That means that by default is 0. So when you use a round, you don't specify these parameter digits. That means that the digits will be 0. But also you can use, I think you can use the interrogation symbol. No, it's No, you need to use the interrogation symbol at the beginning and then write the name of the function. So, and as you will see here, I will make this more. Here you see in the bottom right, you see the help of this. See the arguments, details, methods, warning, references, and examples of this. So you have a complete help of this function. So what the function does is you do round. Well, okay, I will write it here on. And then you specify a number, so you can specify this one, 3.14159, and when you execute it, the output is 3, because yeah, this function removes our digits. Also, if you wonder what the arguments are of a function, you can use the function arch_round. They execute control N. And the output, you see here that the output is, well, this is a function, and you have the number that is x, and digits by default are 0. If for some reason you want 2 digits rather than 0, you will need to specify that. So you will need to use a round, the number, 3.149, comma, and digits equal to. You see here that I'm using an equal rather than an assignment. That's why that's the difference, and that's like why I recommend to use, because when you assign a value to an argument in a function, you must use the equal symbol. But when you are assigning values to variables that are outside a function, like are not defined in the parameter section of the function, you need to use the arrow. So now if we execute that, we will get that the output is 3.14. We have 2 digits. Also, because we are keeping the same order, well, for this is more a question of style. For readability, here we specify the number and we specify digits. Also, we can specify like all of these x equal this number, digits equal 2. And also I can avoid specifying that round. I can say 3.14159, 2. I don't need to specify the. But for instance, this first one is more readable, because you see round, okay, digits 2. So because when you see that, okay, you see that you want to round this number, but maybe you don't know what the 2 means. But if you specify that, you will can make it more readable. And also, in case this function is easy to because only has 2 arguments. But in case that you have a functions that they have a greater number of arguments, and most of them are optional, you will need to specify the name of them in case that you want to skip some optional argument. And also you can use the arguments the other way around. You can use a round, you can use a digits equal to x equal 3.4 over. Oops. And you get again the same output. So this is regarding functions, and now we will start with the learning a little bit more about vectors. That this is a basic data type in R. So we can have the vectors. We can have vectors of numbers. So for instance, we can have okay, we'll keep writing here. We can have a weight underscore G, and again the arrow. And to create a vector, remember that we will use the function call is C. So here in this function, the arguments are the elements of the vector. So I can write the 20, 40, 50, 70, for instance. You need to separate the elements by commas, and here we will have a vector of 4 elements. You see here now that in memory we have a vector of color numeric that has 4 elements and have 20, 40, 50, and 70. But also if we execute this, we get the output that is 20, 40, 50, and 70. There is okay, I see there are some questions in the chat. Here I leave like a space to make this more readable, but there is no need to, you can write everything in the same, like without any, without leaving a space between each line. Also, a thing that I forgot mentioning what is that in other programming languages, you will need to write here a semicolon at the end of the line, but here you don't need to. You only need to press enter, and each line is a new instruction. And there are some functions related to the vectors that could be length. I always forget how to length weight G. As you get the output, you get 4, so it's the number of elements that you have. Also, you can get the class of this vector. The class is numeric, so you are storing numbers, and also you can get the, well, like str gives you the structure of this vector. Gives you like more information. Num, the first part is tells you that it's numeric. Then the second part tells you that this is 4 elements, and yeah, list the 4 elements. There is another comment in the chat that is when is an error that, for instance, if we execute, when we execute a variable that doesn't exist, we get this. We get error object this not found. This is because if we check here in memory we have defined the three values. We have a weight underscore g, weight underscore kg, and weight underscore lb. So this variable is not defined. So when we get errors like that, that means that the variable has not been defined. In this case, if you get the weight underscore g has not been defined, means that you haven't execute this instruction. You haven't created this vector of 4 elements, or maybe you use another name for this vector. Okay, so I see that, yeah, there is another question that can one reference the output from a line in another line? I will answer that later. I think there is a way, but yeah, we need to check that. Okay, what else? This is for vectors. The thing is, you may find for instance, in other programming language, in Python, you can have vectors of different types, but here, when you have a vector, all elements should have the same type. We have worked with the numeric, but we can use the other types, like we can use strings. That is, to define a vector of strings, we can define like a vector called animals, arrow, and remember to use a C. And now in using quotation marks, we can use cat, dog, but there's mouse. And when I execute this, you see that now I have in memory a vector of animals. That the type here is rather than numeric is CHR, that is a character, and I have 3 elements: cat, dog, and mouse. If I want, also we can use we can add elements to the either at the beginning or at the end. So we can use using the function C. We can use animals, arrow. So I create a new vector, and imagine that I want to add a horse at the beginning. So I can use horse, and the second element will be animals. So we will the vector itself. So if I execute that, and I execute animals, well, I need. What it happens sometimes is if you press enter, nothing will happen. I think maybe that's you need to press Control Enter in order to execute the command that you are writing here. Or if you prefer, you can also use you can write to the console this file could be useful when we have we will see tomorrow that we may have instructions that take several lines. So in that case, it will be useful. But for instance, for today's example, so we can later write everything directly to the console. Also, I forgot to mention that here in history, you can see also all of the things that you have executed. So you can also save the history in a file, and it's quite. Or if you want to repeat again something, you can double click on that, and this will be copied to the console. This is one of the advantages of using this like RStudio that makes let's say that makes life easier when you want to code something in R. Let me check if I'm forgetting. Okay, the two types that we have used for vectors having a numeric or double or floating point character, but also we can have a logical that will be true or false. We have an integer, complex, and row. These are the six main data types that. Okay, there is a question that about this line. Here, the function C means that you are creating a new vector. So you have this, the beginning we have a vector called animals that will have 3 elements. In case that we want to add a new element to the vector, what I'm using is the new element. We create a new vector with this new element, and I'm using animals. I'm using this, rather than repeating these 3 elements, I'm using this. So what the C function does is creates a new vector with horse and the 3 elements that have been previously defined. Does it answer your question? Great. Okay, so we have just to play a little bit with the elements. We have this exercise here. I will copy that in the. That is execute. Well, I will copy that in the. I think in the chat. Let me see if yeah, it works. So if you can execute this for and check the type of the vector, and you will see what happens when we mix different elements of when we create a vector. Once that you are done with the exercise, please let me know. I can continue with the lesson. Okay, so I think we can solve this exercise together. That is, let's start with this first one. We have here, you see that we have a vector of, here we have 3 elements, 3 numbers, and we have a character. So when we execute that, sorry, I always is with the control enter, and I see that the structure of num char. You see that these three numbers are converted to characters in order not to lose the, because okay, because would be it's more difficult to, because you don't know if to convert that character to a number, what method do you use? So it's easier to to take the numbers and convert them to characters. So this is just a way to show you that vectors only can have one value, and because these numbers are now characters, if you want to use them for arithmetic operations, you will need to convert them. But yeah, there are functions that you can take a string and convert them to a number. But well, this is just an example of what it happens. So when we execute numerological and str numerological, for instance, in this case, true is converted to 1, because in some programming languages, true is 1 and false is 0. So this is what this is interesting. Logical, I think that true will be converted to a character. We will execute here. So if I execute this, yeah, true is a string. Well, here the tricky one, I imagine that because this is a character, all of them will be converted to characters. So str tricky, yeah, will convert all of them to. This is just an example to show that vectors only contain one type of one data type. Okay, I will start using the console, but you can keep. So, for instance, if I execute animals, I get in the output. I get a horse, cat, dog, and mouse. I get these 4 elements. What if? Well, we will see now subsetting. If I want to get only cat, I can get animals, and I would need to use square brackets to select the index of the element. What number would you use to get the second element? 1, 2. See that there are some people say 1. There are other answers. Well, let's try with 1. So if I execute that, I get a horse rather than cat. Okay, so let's try with 2. Oops. With 2 I get cat. This is the difference. There are 2 families of, let's say, 2 families of programming languages. The ones that start with the 0 as a first element, that could be C, C++, Java, Python, and the ones that start with the 1 as a first element, that is Fortran and R. There are differences. There are like some opinions that say that starting with 0 is better than starting with 1, but it's just like doesn't make that much difference for the level that we will for this lesson, and for R in particular. You only need to remember that if you want to get access to the first element, you will need to use 1 rather than 0. So it's not the. But yeah, for instance, if you use Python or other programming language from that, let's say, family, you will need to use 0, because it's like the idea of using 0 is kind of the offset. So to get the first element, the offset is 0. So to get the second element, there is like an offset of 1 from the first element. So that's the idea. But yeah, in R, we are working more with like a 1. You see that the first element is a 1. There is also, there is an interesting question in the chat that is R runs only the command one line at a time and not everything above it. Here, because we are using this console, this is more like an interactive mode. So this is like more like a calculator. So here executes one line at a time. I think there is a way to, I'm not sure if this with the semi, let me try. I don't know if a semicolon works here. So if in case that you want to execute 2 lines, you can use a semicolon, and you can execute 2 commands. Also, in case that you want to execute a whole file, you will need to go to the terminal, and you will need to execute R and the name of the file, like script.r. So if you execute that, you will execute all of the, let's see, sentences that that script contains. So these are the ways of executing one command or a set of them. Okay, so for subsetting, we are getting 1 element, also we can get 2 elements. To get 2 elements, we will use animals, square bracket, and here I will need to use a vector. I can get the element 1, 2. Sorry. I also can get the elements in a different order, 2, 1. So you can change the order, or you can get a repeated. There is also a way that we will see that also you can, here is like we are selecting based on the index, so where the element is, but also we can use, it's called a conditional subsetting. We can use a vector of true or false. That means that if the position is true, we'll return the element, or if it's a false, we'll not return the element. The sample is in animals. If we create, well, remember that animals has 4 elements. So if we create a vector that is true, 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 it will return these 4 elements. But they say that they don't want the 3rd element, so I click in false. So you get the first element true, the second element true, the 3rd element false, and true. So here you see that you can get only this. You can get this, and also in R it's interesting that you can also use conditions. For if you remember the first the vector that we defined before, that is 20, 40, 50, and 70. You can say with square brackets, give me the elements of this vector that are greater than 50. So when you execute that, you get this the elements that are greater than 50 or greater than 40. So you get 2 elements. Why? Because if we execute this part, what it does is compares the elements, do this comparison with each of the elements that contains the vector. So what you return is a vector that is false, false, true, true. So when you use this vector for indexing, returns the elements that are true. And also you can use weight that is greater than 40 and the weight is smaller than 70, for instance. So you can use you can use 2 conditions to index the. So if you use weight square brackets and the previous condition that we have used, Ctrl+C, Ctrl+V, you get this is using AND. So this condition and this other condition. So both conditions must be true in order to get this is true. We can also learn a little bit how to. This is using numbers, but also we can compare strings. So we can use again using animals, square brackets. You can say the animals are equal a cat. So you will it will return the elements that are equal to cat. And also you can use the OR function, equal to cat or animals that are equal to horse. And you can get that. There is another way that is you can use in. What that this is in case that you have a list in is any. You can say any. The previous expression is similar if you use animals in and you specify a vector of elements. You can say cat, horse. And you get that the first 2 elements are true and the second 2 are false because are not either cat or or horse. So if you use animals and in a square bracket what we have executed before, you get a horse and cat. Also, I'm using now the console, but you can use this here in case that for you is more. I'm not sure if which one is better for you to follow the lesson. If I use this script or if I write straight to the console. Let me know if there is one option that is better than the other. Also, don't worry that all of these commands are in the lesson. That in case that you want to have a look later on, learn a little bit more about them. All of them are in the lesson that I have already shared. Any questions so far? Okay, if not, we will, before going to the morning break, we will learn a little bit more about missing data. You remember yesterday when we were working with spreadsheets, we had some blank spaces that means that it was missing data. That in R, what we use is the concept of NA. So when we define a vector, that okay, we'll go back to the. So in this example, I have used in, no, so it's animals in cat or horse. Okay, so let's learn a little bit more about missing data. I can create a vector that is called height that contains the values could be 2, 4, sorry, 5, 5, and A 6. So if I execute this vector with control enter and then height, you will see here that I have 1, 2, 3, 4, 5. I have 6 elements, and the 5th element is missing data, so we don't know exactly what that is. And the thing is, if we do the average of height, also enter. When I execute the average, I get NA. So I get, why I'm getting that? Because I'm getting we have 6 elements, but we don't know the value of one element. So if I want to get the mean of the maximum, minimum, I don't know. I don't know if this element is 10, is 0. I don't have any information on that. If I want, or well, I use a mean, but I can use a maximum height. I will get the same answer, and A, so it's, I don't know. If I want to, in order to calculate the maximum of the average, I will need to use, I will need to get rid of the elements that I don't know the value. Now you may understand why using, for instance, if I use here 0 or 999 or -9, will calculate the height and it will consider that that element is valid. So if so what I will need to do is admin height, and the second argument I will need to specify that na.rm, well, it tells you that it's a logical evaluating to true or false indicating whether NA values should be stripped before the computation proceeds. So if I use NA true, I will get the average, that is 4.4. And if I use the same, max height NA.rm equal true, I will get the maximum, that is 6. This is when I'm using these functions of mean, maximum, minimum, etc. But also is explained in the documentation, there are 3 ways to remove the NA's values. So one way is can use the vector height, and we can use the conditional subsetting. So there is a function that is well, okay, first let's learn the function is.na, and I need to specify the vector. So the return is false, 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 true, because it's the NA, and false. Also to let's say to return the opposite, or to negate all of these elements, I will need to use the exclamation symbol. So when I execute that, you see that I get the opposite. I get a true, 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 false, true. So now I can use this output to do a conditional subsetting. So when I execute that, I get all of the heights that are not NA. This is one way. Let's see the second way is we can use na.omit. This is another function, and I can specify the vector height. And I get all of these. Well, I get the vector, and also I get like a more output of and also there is a complete cases height that gives me the same output that this one. So again, I can use this to do conditional subsetting. So there are 3 ways. So you should choose personally, but I don't know what you, but I think the first one looks like a more is like a easier, or maybe for me it's easier to remember this first one rather than. So this is normally the one that I use, but this is just to let you know that there are other ways to do that. So we have an exercise, and now we will go for the break. the exercise is the following one. But the exercise is at the bottom of this work. I will copy here in case that you want to copy the vector. So this is the exercise that we will see the answer after the break. Now we have a break until 11:30. And yeah, I see that there is a question in the chat. What can we see? Yeah, there is a question in the chat that is, can we execute a ranking of data weights to show hierarchy in R? I'm not, should be a way, but now doesn't come to, I don't know if, I mean, the first thing that comes to my mind is maybe to create another vector with the weights, but this, I'm pretty sure that must be a more intelligent way. I will have a look during the break and let you know after the break the answer. Also, I will answer that the break one question that was before in the chat that I didn't answer. But yeah, let's have a break, and after the break we will have some time to go through the challenge and keep learning about R. Okay, I think we can solve the exercise together. So the exercise said using this vector of a height in inches, create a new vector, height no NA, with the NA removed. So we have this vector, and they said that create a height underscore NO underscore NA equal, or equal like a designation symbol. Remember that is with the alt minus. And the method that we use, we can do select height is dot NA height. So we can execute that. And if I print height NA, sorry, because I used the previous, my mistake, it's a height with a S. If I execute this again, because I can check the length of both vectors, heights. So yeah, one has 21 and the other one has 19 because this element is gone, and is this element as well. Also now using the function median to calculate the median of the height vector. So median, the vector is a height. And remember that you can use na.rm true, because by default it's a false, in order to calculate the median of this. That is 64. And also it's a user R to figure out how many people in the set are taller than 67 inches. So you can use height, no, NA, and say that height, no, NA, is a grade taller than 67 inches. So you get that, and also you can use length, if in case that you want to get the number. And the answer is 6. So you have 6 people in the set that are taller than 67 inches. If you want to have the details, here are the heights. So any questions regarding this part? If not, we will continue with now we will start working with the data. What we will do is we will download the CSV file, and we will load it to memory and use it using what is called a data frame. So what do you, I see that there is a comment in the chat to get the solution of the last. So the solution is well, the answer is 6. So what I have done is I filter the vector and saying that they give me the elements that are greater than 67, and then I use the function length to see the length of this vector. I'm not sure if, yeah, is the, yeah, thanks, Rui. What I can do is later I can copy that to the, share path. So, okay, so what I will explain now is the this okay, the structure that we will use. So maybe it's easier if I share this in the here. So now we will work with a data set that is survey data. So in this survey, we are investigating the animals species diversity and weight found within plots and our study site. So we have a CSV file, and we have the following columns. We have a record ID, that this is a unique ID for the observation. We have the date in format month, day, and year. We have one column for each value. So we have the plot ID. So the plot means like a plot of land. So each animal will belong to a plot. So we have the species ID, that this is a 2-letter code. We have a sex of the animal, that is could be M or F. The hind foot length, in millimeters, the weight of the animal in grams, the genus of the animal, the species, the taxon, could be there are 4: rodent, reptile, bird, and rabbit, and the blood type. This information is the one that we mentioned yesterday that could be in a separate file rather than having that in the CSV file. The CSV file, we want only to have the data that we will use. So let's go back to the RStudio, and now I will write here starting data. And what I will do now is I will download the file. To download the file, I will execute the following line. I will copy that in the chat. Sorry, it looks a little bit ugly in the chat, but what I will use is this one. So I will use this command, download file, where the URL is this one, and I will save the file in data row, and I will call it the file portal underscore data underscore join.csv. So if I execute that, I get that message that I have downloaded the file is around 3 megabytes. And if I go to files and I click in data row, I can see my file that has been downloaded. If I click on it, you can see view file, import dataset. And also, well, I get a warning that the file is large, it's 3 megabytes, and might take some time to load it. But yeah, I can open it and I can see that the first line of the file is the names of the columns and then the data in separated by commas. But what I want to do is I want to load the file to start working with it on R. And what we will use now is we will use a library on R. The library is Tidyverse. Tidyverse is kind of, I don't know if it's like a like an umbrella. It's like at the same time it's a set of libraries. So when we load the Tidyverse, other libraries will be loaded. This library is will be useful to read the CSV file that we want. So to load the library, I need to type library and the name of the library, that is Tidyverse. So when you execute Control Enter, it takes some time because it's a big library, and I get this output. So I get the packages that are loaded are ggplot2, that is for, we will see tomorrow, for plotting, table, that is a type of a data frame. I think tomorrow we will use TDR. So all of these, we have loaded all of these packages. And this conflict here means that if we execute a filter, it will execute deploy filter rather than a stats filter. So it's like there are two function names that will use this library rather than this one. In case that we want to use this library, we will need to specify the name of the library, double colon, and the name of the function. Is this working for everyone? There is a question in the chat that the thing is to load the file, we will use a function that is in the library, in the tidyverse library. I'm not sure if using R, you said that this, I mean, the file could be open if we, not sure if import dataset. Well, we can use import text, and we can use this yeah, we can use that to but what we will do is we will do it like manually. I mean, we will be the same. We will do this. We will execute this. Actually, I can copy this. So manually, to load the file, we will use the variable color surveys, and we will use read. This is important here. There is a read.csv, but this one creates if I use this one, read.csv, creates a data frame and use the library utils. We want to use the library, tidyverse. So remember that you need to use read_csv. This is from the library and read R. So the package read R that is inside the library tidyverse. So here, what I do is I specify the where the file is, that is the data row slash portal. Also, if you click here in tab, it's autocomplete. So when I execute that, I get this output. I get the number of rows that I have, and read is 34,786, 13 columns, and also tells you the column specification. The delimiter is a comma, and the character will be 6 columns. So it will be species ID, sex, genus, species, taxa, and plot type. And double will be record ID. Double is like a numeric floating point number. Record ID, month, day, year, plot ID, input length, and weight. What this function does is read the first 1,000 rows and detects the data type, gets the data type based in the first 1,000 rows. There are other functions. If you use read_csv2, is in case that you are using semicolons rather than columns to semicolons rather than commas to delimiter the columns. This could be the case in some, like in Spanish, it's use a comma for a decimal point rather than the point. So this case may be needed to use a semicolon to separate the columns. Or imagine that rather than using a CSV file, you're using a tab separate file, so you can use read_tsv. So there are several ways to load it. So if we want to see the contents, we can do can execute here head surveys. That this will print the beginning of the table, So table is a data frame where we have the columns, record ID, month, day, year, plot ID, species ID, sex, input length. Also, if it's because the window is not like wide enough, the names that are shortened appears here, like the full name. So with the header, you print the first six six. You can also specify if you want to print more, so you can say head surveys, for instance, the first 10. So you print the first 10. Well, it returns a table of 10 rows or 13 columns. Also, you can use view surveys. If you execute a view, you open on the top left, you open, looks like it's more like a spreadsheet where you can see a record ID, month, year, and also if clicking the columns name, you can sort. Also, you see that the data that is missing appears here as NA. So here we are using a table. Is like it's a data frame, but have some. They see that the data frame is like, let's see the original template of the, let's see, the original class, and table is a class that is it seems that is more efficient than the data frame, because some features that are less used are removed and also contains other features. So I see in the chat that there are, if when you execute library tidyverse and you get an error saying that there is no package called tidyverse, is because you need to install the library. So to install the library, you need to execute well, I will copy that in the chat, and also I will copy that in the. You will need to do this. Install packages tidyverse. This installation will take some time, so don't worry about that. It will take some minutes because you need to download and compile several packages. But to install a library, you will need to. Okay, any other questions so far? So here again, we can use str with the surveys. With str, we will get a summary of this data frame. So you see all the columns that I have, and a smaller summary of like the type, that is either numeric or chart. I get the length of each column, and also I get like a snapshot of the first elements. And also I get here how these are defined with the double character, etc. Also I can get the dimension of surveys. So I get that the number of rows are more than 34,000, and the number of columns are 13. But also I can execute enroll surveys or encall surveys. To show the first, I use head, but also you can list the last 6 with the tail. In case that you want to use, you want to get the names of the columns, you can execute the names surveys, and you get a list, a vector with the names of the columns. And in case that you want to get there is also another function that is a summary that gives you for each column gives you the minimum. Well, I think this is could be useful for weight or input length. For the others, might not be. For weight, you get the minimum, the median, the mean, and maximum, the number of NAs. Also for character, doesn't give that much. Summary is more for numeric data. Okay, so we have seen how to use how to load a data set into memory in order to work that with R. So we have downloaded the data set, and we have we have saved it in the variable called surveys. And now what we will learn is how to index and subset data frames. So remember that for vectors, we have used the square brackets, and for here we can use also the same. If I want the first column and the first row, I can use surveys 1, comma, and 1. So executing that, I get the first column, that is a record ID, and I get the first row, that is 1. If I want to get the first row and the 6th column, get first row and the column 6. So I get species ID rather than record ID, and I get an L, that is the first. Also, for some reason, if I want to get the number of the first row and all columns, is easy surveys for brackets. So I specify the column 1, but sorry, I specify the row, that is 1, but I don't specify the column. So when I execute that, I get all of the columns, but and the first row. I can do the other way around and select the first column. If I don't specify the row, I will get all of them. So you see that this the set tells you that it's a table of all of these rows and one column. More ways to select the first column. You can also use a surveys 1 rather than specifying row and column, to just specify the number of the column. What else we can do with the you can also get specify With the square brackets, you can either specify with a vector that you want to get the rows 2 and 3, and you want to get the columns 5 and 6, for instance. So this is the row number 2, the row number 3, and the column number 5 that is plot ID, and the column number 6 that is species ID. Also, there is a way to get a range of elements that this is using the column. So if I use a surveys, if you want to get the first 3 columns, you use from 1 up to 3 using a column, and I want to get the columns 5 and 6 of, well, okay, 5 to 7. If I execute that, I get the rows of 1, 2, and 3, and I get the rows 1, 2, 3, and the columns 5 that is plot ID, 6 that is a species ID, and 7 that is a sex. You may notice when I when I got the first column, surveys one, that I got the output that I get is a table. I get another data frame. But if, for instance, I want to get a vector, I will need to do surveys. I will need to specify or to write twice the square bracket. And you see that now the output that I get is different, because in the previous one I was getting a table, and here now I get a vector. And the same before I was getting surveys 1, 1. I was getting a table of or a small data frame, but if I specify a double square brackets, I get the element itself. This is using numbers. If because the columns, all columns have a name, I can use the name of the columns. So I can use surveys square brackets if I want to use the column species ID. I can specify the name of the column when I get it. Another way is to use surveys and use the dollar symbol as a species ID. But in this case, if I use this syntax, you notice that I get a vector rather than a table. Table data frame is same, I mean, for this lesson. Any questions? So, okay, what we will do now is we will do another small exercise. That is create a data frame called surveys underscore 200 containing only the data in row 200 of the surveys dataset. So when you do the exercise, please say so in the chat, and also again, if you have any questions. So now that I remember, it was a question that executing the data weights to show a hierarchy. One way, have checked that, one way could be to use a data frame, and one of the columns could be weight. So with that column, you can play with the weights. But I have seen on the internet that there could be other ways that you can work with the weights. And also another question that was in the chat that was asking to reference the output from a line in another line. I think the easiest way is to save the output in a variable and use that variable in the upcoming line. Okay, so let's solve this exercise together. So if we have this that create a service to handle, oops, that containing the data in row 200 of a service data set. So I will need to use a service indexing on the root 200, and I don't specify the column. So I need to execute that, and if I print service 200, well, this is like a basic. Okay, if you have any questions, feel free to put them in the chat. If not, I will continue with the next part of this lesson that will be now we will talk about factors. I'm not sure if you're familiar with this concept. Factors here in R are useful when we work with categorical data. Categorical data means that that data could only take on a limited number of values. So for instance, one example that we will see here is with the surveys. There are some columns that contains categorical data. For instance, species ID, but we will work with for this example, we will work with the column sex. In case that when we read we do str surveys. So when we read the data frame and load into memory, we got this, we got that sex. We save it as a character. But if we want to change that column, what we can do is surveys $sex assignation, so the arrow, and we will create a factor with the function factor and the name of the so it will be surveys $sex. So if we execute that, and now again I show the structure of a surveys, you will see that this has changed. So now I have a factor with two levels. That is, could be F or could be M. And what it does internally use a number to save the, so if his male is 2, or if it's a female, use 1. Okay, if you don't know, use an 8. So just to play with we can create a variable called sex that we can use a factor, and we can specify a vector that could be male, female, female, male. Remember to use quotation marks. And here what I'm specifying is I get this vector, and what I want is I want to create a factor of this. So I click in enter, and now if I type levels, sex, I get the 2 different types that I have, female and male, and also I can get the number of levels. That is 2. You may notice that it's getting like a female and male because it's sorting using the an alphabetical order. F goes in the dictionary is like goes before than M, so that's why it's getting that order. So if we execute sex, we get the vector, and also we get the levels. We get this order. If for some reason we want to change the order, we will need to execute the following. So sex, arrow, I will need to use a factor, sex, again. So I'm reusing this. But here, what I do is I can specify the levels, the order. So I specify a vector, and if for some reason I want to put first male and then female, I can do that. When I execute that, if I execute again sex, you see that the order have a change. So now male will be saved as 1, and female will be saved as 2. So for that, we will do another exercise. I will copy this here. Okay, I asked you a question in the chat, but I didn't receive any answer. I wonder if you are still there, or you are working with the exercise of. I know that this time is now closer to lunch time, so maybe the energy levels are not that high that as this morning. Yeah, please let me know if. Otherwise, I suppose that everything is okay and can continue. So shall I continue with the? Is that we will finish? Yeah, I think we can finish with the the exercise. See a little bit more about the factors, and we can go for the lunch break and continue tomorrow. Tomorrow we will continue also with the R, and we will learn more how to get some statistics from the data and also do some plotting. Okay, so the challenge is change the columns taxa and genus in the survey's data frame into a factor. So this is surveys dollar taxa to assign factor, and I use again the same the name of the column, surveys taxa. I will do the same with the genus. So it's a surveys genus assignment factor surveys genus. So I execute that is I will need control. So now if I do str, so now I'm typing again in the you will see that now the column sex is a factor, genus is a factor with the 26 levels, and taxa is a factor with the 4 levels. Also the questions are how many different genera are in the genus column. So checking that we can answer that is we have 26 levels, so 26 different genera. And how many rabbits were observed? I think if we do now summary of surveys, I see that they were talking rabbits. So if you see now taxa, when each character doesn't give you any statistics, any summary, but because this is a factor, you get the number of each element. So the question is for rabbits, so the answer is 75. I think also you can get the summary of a column. So yeah, here you can get the number of elements for this. So before we finish, okay, before we finish, okay, so what we, okay, I will copy here in the, yeah, thanks, Rui. So these two first lines are to convert the factors. We have a str and summary. So the last part of this is for the factors is okay. We'll continue typing here. Maybe I guess that this is easier. If I do share summary of the surveys $6, you see that I get female, male, and NAs, but NAs are not considered in the, because also another thing that we can do with the factors, we can generate a plot. So if I do surveys for sex, use the function plot, and the parameter or the argument will be surveys $6. If I execute that, you will see the plot in my right hand side, and you see that this plot the number of females and the number of males. because the levels that are considered are only true. We don't consider NAs. In case that we want to consider NAs, we will need to use the following. Okay, in order not to modify what we will do is we will create a variable called sex that it will contain surveys $sex. So in that case, we don't modify this column here. We make a copy of the column. So now to add an A, so if I do plot sex, I should get the same. You see here that it's the same. But what I can do is can do sex, add an A, sex. So if I plot now sex, here I will get FM and NA. Here NA is not printed because it's not clear. So we have levels sex. So we have FM and NA. So one thing that we can do is we can rename the level for some reason. The way to do that is levels sex, and here I use the square brackets to get the index of NA is a 3. So this is like a 1, 2, and 3. And here I can define that the third level will be undetermined. So if I execute that, and now I plot again set, well, I can do levels, sex. You see that now I have a different levels, FM and undetermined. And if I plot again, sex, here now I get, well, it's quite long, like undetermined. And also, well, that is an exercise, but you can rename the others levels sex. You can rename the first one. That there will be the first one is F, so we can use female and levels sex 2. We can use male. Again, if we plot because sorry, I didn't execute that. Get a female, male, and undetermined. And if I change the levels, I get that rather than FM or NA or FM determined, now I get a female, male, and undetermined. Also, one last, yeah, this is to get so if I execute sex, I get this as a factor, but in case if for some reason I want to get a vector of characters, I will need to use the function as character. This is to get the factor and convert it to the vector of characters. So if I execute that, you see now that the output is different than the previous one. And this is the part of what I wanted to cover about factors. There is also a part about the dates, but we will see that tomorrow when we have more energy. Are there any questions before we close this session. What I will do is I will share with you in case that you have any questions in the afternoon. I will, you can ask them in the share pad that is here. Okay, so yeah, that's the end of today's session. Tomorrow we will continue with learning more about R. Again, any questions that you may have this afternoon, please write them in the chat that I share in this Blackboard Collaborate chat. Okay, have a nice lunch break and see you tomorrow. Bye for now.